Okay, we will go through some important points in the class 11 physics chapter 9 mechanical properties of fluids. Okay, two-thirds of the surface is covered with water. Solids and liquids have fixed volumes, whereas gas fills the entire volume of the container. Pressure, the definition of the pressure is force by area. Impact, this is known as the pressure is force by area. This force inside this container, the direction of the force is normal to the surface. Okay, this is the area of that, then it is normal to this force. Pressure is force by area. So pressure is a scalar quantity. The unit of pressure is Pascal, that is Newton per meter square. Force is in Newton. So you see the definition, force by area. Force in Newtons, area is meter square. So Newton per meter square is the Pascal, that is the pressure unit. 1 atm atmospheric pressure is this 1.0, okay, this many pascals. Okay, 1.013 into 10 power 5 pascal, 1 atmospheric pressure. Density is equal to mass by volume. Okay, so mass is m, the volume is L3. So m L power minus 3 is the dimension. Kg per meter cube is the unit, SI unit. That is also a scalar quantity. This is the density of hydrogen. You see, much less than water. This is density of water is hydrogen, that is a gas, is much less than water. See, whenever a problem is given, you see what is here, they are given mass, not the weight. Okay, so here that is mass, so weight is mass into gravity. Okay, g 10 meter per square, meter per second square. Difference between the mass and weight you should know. Mass, weight equal to mg, mass into acceleration due to gravity. Pascal's law. Variation of the pressure with depth. Okay, pressure difference into area of cross section is equal to mg. The difference between the gauge pressure and the absolute pressure. Gauge pressure is the difference between the atmospheric pressure and the pressure inside that absolute pressure inside that certain depth. P is the absolute pressure at certain depth, and A is the atmospheric pressure. The difference is the gauge pressure. Gauge pressure is the difference in pressure. Okay. So here atmospheric pressure, here some pressure means the difference is the gauge pressure. This is the density of the water, 1000 kilogram per meter cube. Okay, density of the water. Okay, submarines is designed to withstand the enormous pressure. How much pressure you can go through this problem? Okay, this is 1 atmospheric pressure. Pressure at particular depth is equal to density into acceleration due to gravity, and that height. Rho is the density of the mercury here. Okay, any liquid, this formula is valid. This is 1 tar equal to 133 Pascal and 1 bar equal to 10 power by Pascals. So this is finding the atmosphere, height of the atmosphere based on the density. They are given the density, then you are finding the H. Okay, P equal to rho g H equal to P by rho g. So height of the atmosphere using the density. How they detect the low pressure? Okay, 760 mm of this mercury, a drop in the mercury level by 10 mm or more is a sign of approaching storm. Okay, this is how they detect the low pressure using that mercury tube. Okay, these problems, this is the Pascal's law. Okay, Pascal law of pressure. Whenever external pressure is applied to any part of the fluid contained in a vessel, it is transmitted undiminished and equally in all directions. That pressure is transmitted equally in all directions. This is the another form of Pascal law. Okay, and it has many applications in this. So whenever you external pressure is applied to any part of the liquid, the pressure is transmitted in all directions. Water is considered to be perfectly incompressible. Volume avoided by the movement of the smaller piston inwards is equal to volume moved outwards to the larger piston. Hydraulic brakes in automobile also works in the same principle. Streamline flow. What is streamline flow? Steady or streamline flow. The meaning of the streamline: a typical trajectory of the fluid particle. B, region of the streamline flow. Okay, streamline flow. The path, what is streamline? A path taken by the fluid particle under a steady flow is a streamline. Okay, under a steady flow is a streamline. It is defined as the curve whose tangent at any point is the direction of the fluid velocity at that point. Okay, streamline flow. So this is the equation of continuity. That is AV equal to constant, area of cross section into velocity equal to constant. This is based on the conservation of mass. Okay, area into velocity is constant based on the conservation of the mass. So what is a turbulent flow? Okay, streamline flow and turbulent flow, the difference you should know. This is turbulent, this is streamline. Streamline flow, turbulent flow, this velocity differs here. Bernoulli's principle. So this Bernoulli's principle is applied for the streamline flow only. It is not applicable to the turbulent flow. Okay. This works based on the conservation of energy. See, this law of continuity is based on the conservation of mass, but Bernoulli's principle works on the conservation of the energy, law of conservation of energy. Okay, this is the Bernoulli's equation. This is the kinetic energy part of it, gravitational potential energy. Okay, if you take 2 points, their pressure at that point plus this kinetic energy is gravitational potential equal to pressure in another point plus the kinetic energy and potential energy. Okay, that is a Bernoulli's equation. So here see, you see the velocity as a power up to velocity has more weightage than the pressure. So this is only for the streamline flow, Bernoulli's theorem. Okay. So when velocity is zero, that is at rest, so this term will become zero, that is kinetic energy. So we will have only potential energy, pressure plus potential energy equal to this. Okay, V at rest. Continuity. This is the free fall. Velocity of a free fall object is independent of the mass. You see 2gh only. So that is independent. If you drop two objects with different mass, they will reach at the same time. It is independent. Freely falling body velocity is independent of the mass. Dynamic lift. This is the ball moving with spin. Why it is not taking the parabolic trajectory? So due to this Magnus effect. What is Magnus effect? The difference in velocity of the race, there is a velocity of air above the ball related to this is ball moving with spin. Okay, velocity of the air above the ball related to the ball is larger and below is smaller. Okay, the difference in velocities of the air results in the pressure difference between the lower and upper phases. So there is a net upward force on the ball. The dynamic lift due to the spinning is called Magnus effect. See how aircraft flies due to the Bernoulli's principle. Okay, this v2 square minus v1 square a square minus b square equal to a plus b into a minus b. That formula is. So this is the problem. You can go through it. What is viscosity? Viscosity is nothing but resistance to flow. Okay, this resistance to flow the motion is called viscosity. Honey is more viscous than oil. What is laminar flow? Laminar flow, the bottom is fixed, the top has some velocity. Okay, laminar flow. See here some velocity, but bottom is there is no velocity here. Velocity distribution. Coefficient of viscosity formula. The unit of viscosity is Poisson. Okay, PA. It is Pascal second. Pascal Newton per meter square, then second. Okay, blood is more viscous than water. Viscosity of the liquid decreases with temperature. See, viscosity of the liquid decreases with the temperature but increases in case of gas. So, viscosity of the gas increases with the temperature, viscosity of the liquid decreases with the temperature. Blood, viscosity of the blood. Stokes law. Retarding force. What is terminal velocity? You can go through it, okay? Surface tension. Force per unit length is surface tension. See, this is the a molecule inside a liquid. It has attraction with different molecules in all direction. But on the surface, there is nothing above the surface. So only this force of attraction is below only. Okay, above the surface. See here, this is inside the liquid. This is on the surface. So you see on the surface there is a difference in energy that causes surface tension. Half of the kit, so it has one half of the energy. This is repulsion force. A is the attractive force. This is the force per unit length. F by 2L is the surface tension. Pressure is force per unit area. F by A. Surface tension force per unit length 2L. Okay. Force per unit length, surface tension. Extra energy that the molecules at the interface have, as because it is only one direction, so it has extra energy at the interface, surface tension. Surface tension, value of the surface tension depends on the temperature. Like viscosity, surface tension at a liquid falls with the decreases with the temperature. Inverse relation, okay. This is how you measure the surface tension. The length of this glass plate is L. Weight by 2L. Weight equal to mg. L is the length of the plate edge. Angle of contact. Tangent to the liquid surface at the point of the contact on the solid interface inside the liquid is an angle of contact. This is the angle of contact. Tangent and the solid interface. This is obtuse angle. Obtuse, that is greater than 90. Greater than 90 is like mercury or water in a lotus leaf. Okay. This is acute, less than 90. Okay, this is on a plastic plate. See here, greater intermolecular interaction. Here, less intermolecular interaction, but more interaction between the water and the plastic plate. Obtuse angle, the molecules of the liquid are attracted strongly to themselves and weakly to the those of the solid, okay, strongly to this themselves, that is intermolecular interaction is more within that liquid, and weakly to the this surface, that solid. But here they strongly to this surface, but the intermolecular is weak here. This is droplets. For the droplet, spread over, there is a weak intermolecular interaction. Drops and bubbles. So why bubbles? They have spherical shape. For a given volume, the surface with minimum energy is the one with the least area. So the sphere has for a given volume, sphere has the least area, occupies the least area. That is why these droplets, that bubbles having spherical shape. Excess pressure, this is P inside and PO is the P outside. Okay, this is outside pressure and inside pressure. Outside pressure is the atmospheric pressure. This is for the air bubble, this is for the soap bubble. It has two surfaces. For the air bubble, we have excess pressure 2S by R. But for the soap bubble, we have 4S by R. Important, okay? 4S by R. But for the air bubble, 2S by R. So, yeah, okay? Capillary lines, these two surface tension, water flows, okay? This is enlarged view. Here you see what is R, what is A, and the theta, okay? Curved at the top. This is acute, less than 90 degree, that theta. Concave. When this A is less, see the A from middle here, when it is less, then there will be more capillary. More capillary rise. So this is acute, glass and water. So when A is small, then capillary rise H will be higher. Okay. When A, see this tube, if it is less, means this length is less, means the H will be more. Okay, it will rise to the higher level. Capillary rise will be more because H, you see, inversely proportional to A. Mercury convex shape at the center. So this is again Y 2S by R, Y 4S by R. Okay. So bubble and air bubble above I have shown you. Excess pressure. Okay. The summary you can read. Pressure equal to force by area. These things we already seen, but you can go through it again. These are the dimensions. Okay, you should derive this dimension based on the definition. Example, surface tension, force per unit length. Okay, force per unit length. Pressure, force per unit area. Density, mass by volume. Like that you have to, from that you should derive that dimensions. Okay. Okay, exercise. Explain why the blood pressure in humans is greater at the feet than at the brain. Okay, so here pressure is equal to rho GH. So H is more at the feet. Pressure equal to rho gh. Rho is the density of the blood here. G oxidation. So here h is more at the feet than at the brain. So the pressure will be more. P is directly proportional to the h. H is the height of the liquid. Okay. Atmospheric pressure at the height of about 6 km decreases nearly half of the value at the sea level, though the height of the atmosphere is more than 100 km. See here, you see pressure. It depends on the density of the air. The density of the air decreases as you go up. Okay, so it is at 6 km. The density is almost half than at the sea level. Okay, rho, the density of the air decreases as we go up. Okay, it is half at the 6 km. Hydraulic pressure is a scalar quantity even though pressure is force divided by the area. So this hydrostatic pressure is transmitted in all directions equally. So it is directionless. So it is a scalar quantity. See here, whenever external pressure is applied to any part of the fluid contained in a vessel, it is transmitted undiminished and equally in all directions. Okay. Explain why the angle of contact of the mercury with the glass is obtuse while the water with the glass is acute. Acute is less than 90, acute obtuse is more than 90. Already shown, if in mercury the intermolecular force of attraction is more than between mercury and glass, but in water, within water molecule the attraction weaker than the water glass interaction. Okay. See here, this is substitute. Here, the intermolecular force of attraction is more than between the liquid and the solid surface, the attraction. But here in this case, the between water molecules, the attraction is less than between water and the that solid. Is in case glass. Okay. Angle of contact, obtuse and acute. Obtuse greater than 90 is like in case of mercury, strong attraction between the liquid molecules. So it is convex shape. Okay, like this at the surface. Okay, but in the water, the liquid between the water molecule interaction is less than between the liquid and the glass. So it is like a concave. This kind of shape at the surface is an acute angle. So water on a clean glass surface tends to float while the mercury on the surface tends to, so the same the explanation. Okay. Intermolecular force of attraction is more than between mercury and the glass, whereas in water intermolecular less than water and glass interaction. Surface tension of a liquid is independent of the area. Surface tension is weight by 2L, force per unit length. It is nothing to do with the area. So it is independent of the area. See here, this is independent of the area. Water with detergent dissolved on it should have the small angle of contact. Yes, surface tension decreases when you dissolve a detergent with water, so the angle of contact decreases. A drop of liquid under no external force is always spherical in shape. So I already told you why spherical in shape, because sphere has the least area, occupies the least area for a given volume. For a given volume, sphere occupies the least area for a given volume. Okay. Fill in the blanks using the words. Okay. Surface tension of the liquid generally dash is decreases with the temperature. Okay. Viscosity of the gases is increases with the temperature, whereas viscosity of the liquid decreases with the temperature. I already shown you. See here, the viscosity of the liquid decreases with the temperature, while it increases in case of gas. Okay. For solid with the elastic modulus of rigidity, shearing force is proportional to the shear strain. For fluids, the proportional to the rate of shear strain. Okay, page 12. So here this rate of shear strain. Okay. For a fluid in a steady flow, the increase in its flow speed at a constriction follows the law of conservation of the mass. This is the law of continuity. Okay. This is the conservation of mass. Okay, AV equal to constant. For a model of a plane in a wind tunnel, the turbulence occurs at a greater speed. Explain why. To keep a piece of paper horizontal, you should blow over, not under it. Okay, when you blow over the paper, the velocity increases with pressure decreases above the paper, but below the paper there is atmospheric pressure, so paper will be in horizontal position. Okay. So this is the formula. Okay, this will be constant. Okay, whenever pressure decreases, then there will be a lift. When we try to close a water tap with our fingers, the jets of air gas, okay, because AV equal to constant, we are reducing the area, so velocity will increase. Okay, law of continuity. I already shown AV equal to constant. The size of the needle of the syringe, okay, so here our kinetic energy depends on the velocity power square, okay. So the pressure exerted by the doctor while administering flow rate better than the thumb pressure, okay. So here you see velocity is square than the pressure, which is power 1, so this contributes more. A fluid flowing out of a small hole in a vessel results in a backward thrust, that is conservation of the momentum. A spinning cricket ball in the air does not follow parabolic trajectory because due to the Magnus effect. I already shown you. See here, ball moving with spin due to this Magnus effect. $50 kg girl wearing high heel shoes balances a single heel. The heel is circular with the diameter. What is the pressure exerted by horizontal? Okay, so there is a pressure, different formulas are there. So what is given in the problem here, based on that you should use the formula. Okay, 9.5. Pressure here I am using force by area. So area is 5r square. Okay, r equal to diameter they are given. So you find out the radius. Mass into mass they are given. Acceleration due to gravity 9.8. Okay, so the pressure is force by. Okay, like that, based on what data here we are using rho gh, that is also pressure. Okay, barometer use the mercury. Pascal duplicated using the French ion of density. Okay, this much. Determine the height of the ion column for the normal atmospheric pressure. Okay, this also using pressure is equal to rho gha. Rho gh, we have to find the h. H equal to pressure by rho, density into the gravity, acceleration due to gravity, that is 9.8 meter per second square. Okay, after substituting h 10.5 meter. A vertical offshore structure is built to withstand this much pressure, stress of 9 power 10 power 9 Pascal. This structure is suitable for putting up on top of the oil well on the ocean. Take the depth of the ocean is around 3 kilometer. Ignore the ocean currents. 7. Okay, depth of the ocean is 3 kilometer. P equal to rho gh. Okay, P equal density of water 10 power 3 into G into H. H depth is given. This is the pressure. Okay, but this is pressure is less than 10 power 9. That is it able to withstand. So this structure is suitable. Okay. Yeah, hydraulic automobile lift is designed to lift the cars with the maximum mass of 3000 kg. And the area of cross section of the piston carrying is this much. What is the minimum maximum pressure would the smaller piston says we have 9.8 pressure. Here you see force equal to pressure by area. Sorry, pressure equal to force by area. So force is the mass into acceleration, that is the force. So the area of cross section is given. So pressure equal to this much. Okay, a U-tube contains water and a methylated spirit separated by the mercury. The mercury columns in the two arms is 10 centimeter of water and 12 centimeter of the spirit, the water. What is the specific gravity? Specific gravity is the density of the substance, air spirit divided by the density of the water. Any substance, air is spirit, okay? So here this is the velocity, viscous velocity is 0 at rest. So we are going to use this formula. Okay. See here 10 centimeter, here 12.5 centimeter split. So at this point A and B, they will have the same pressure. We at rest, we are going to use that formula at rest. Bernoulli's P atmosphere, that is outside, plus rho gh equal to E. So these two will cancel out. G also will cancel out. So density of the spirit divided by density of water equal to height of water divided by height of spirit. Okay. Density of spirit is less than the density of water. Okay, this is the specific gravity. See here, the pressure at the A pressure B and same, but here this height is different. So this spirit needs more height to create the same pressure here, because the density of this spirit is less than the density of water. Okay, in the previous problem, 15 centimeter of water and spirit are further poured into the respective arm. What is the difference in the how the mercury level will change? Because there 10 centimeter, 12 point centimeter is balancing the pressure. Now we are adding the more water and spirit. So how the mercury level will vary? Okay, now the total is 25 centimeter. This is water. Spirit will be 27.5. Okay. Now again use this difference in H of this mercury is equal to the difference in pressure of the water and spirit. After equating, you will see the height of the mercury difference is this. Okay, on the spirit side, because that spirit side, because we are adding spirit side density will be less than the water, so the height will be more at the spirit side. Can Bernoulli's equation be used to describe the flow of through a rabbit in a river? That is a turbulent flow. So it's only applicable for the streamline flow. Okay. So it is only applicable for the streamline flow, steady or streamline flow. Does it matter? Does it matter if one uses gauge instead of the absolute pressure in applying Bernoulli's spring? No, it does not matter. Because this pressure is there on the both sides. Okay, this is the Bernoulli's principle. This is the absolute pressure. So if we use the gauge pressure, so these terms will cancel out. This absolute pressure minus atmospheric pressure. This side also same thing is there. So that will cancel out. Okay, so it does not matter whether you use absolute pressure or atmospheric pressure, but there's these 2 points should be at different pressure, P1, P2. 13 grazing closely 30 of the horizontal. Okay, so here they are asking what is whether to check is a laminar flow. So I took this from the net. It is in the book, it is not given details about the laminar flow. So I took these details from the book. Okay, density is equal to mass by volume. Okay, then after that finding this Reynolds number, or that is not actually given in the book, maybe in some other chapter. So that number comes out with 0.3, that is less than 2000, mean it's a laminar flow. So you can this is how they have derived from the net. I took it from the net. And a test equipment, the model of the aeroplane in a wind tunnel, the flow speeds on the upper and the lower surface of the wing are this much respectively. What is the lift on the wing? If the area is okay, take the density. Bernoulli's principle. Okay, so here we are assuming the at same height, so rho gh will cancel out. So this pressure difference is this much. This is in the upper side, this is on the lower side. Okay, the lift is this formula. Okay, this much lift, this much newtons is force, that is the lift. This is Bernoulli's equation that is given in the page number 9. Figure 9.2 and B refer to the steady flow from the viscous liquid, non-viscous liquid, which is two figures are incorrect. Why? Okay, as per the Bernoulli's principle, this here there will be velocity is more, then when pressure will be less here. Okay, so this is incorrect and this is correct. Here velocity is high and the pressure is low. Okay, this B is correct, A is incorrect. Bernoulli's theorem. In a cylindrical tube of the spray pump as a cross section, okay, at the end of it there is a 40 fine holes of the diameter. If the liquid flows inside the tube is this much, what is the speed of rejection? This is using the flow of continuity, AV equal to constant. Okay, area of the 40 holes, one hole is pi r square, 40 holes is this much area. A1 EV1 equal to A2 flow, AV equal to constant. So the VT is the velocity at the hole. Okay, centimeter square to meter square converting. After that you see 0.64 meter per second. So it is given in meter per minute. We have converted that into meter per second. See here I have divided by 60 to convert into meter per second. A U-shaped wire is dipped in the soap solution and removed. The thin soap film is formed between the wire and the supports weight of okay this much. Surface tension of the film. Okay. Page 16 I already showed you the formula. Surface tension. Okay, F equal to mg by 2L, that is W weight by 2L. L is 30 centimeter to the meter. 30 centimeter to the meter. Okay, mass mg already given, so the surface tension is this much. So this is the weight they given, mg is already given. Okay, figure 9.21 A shows thin liquid film supporting small weight. Okay, what is the weight supported by the film of the same liquid at same temperature in B and C? Okay, here this here same weight same length, so S will be same. S will be same because W by 2L is the S, so here 2L is same, W is also same, then S will be same. What is the pressure inside the drop of mercury of radius this much at room temperature? Surface tension of the mercury at the okay. Excess pressure. Okay, excess pressure is 2S by R. I already for the mercury it is 2S by R. Two S by R. This is the pressure difference 2S by R, where surface tension, then the R. The P inside is 2S by R plus P outside. Outside is a atmospheric pressure. Okay. So this is the excess pressure. Inside pressure and this is the excess pressure. The excess pressure and the inside pressure. So what is the excess pressure inside the bubble of a soap solution of radius? Okay, you see here there is a difference between the air bubble and the soap bubble. Okay, soap bubble has two surfaces, that is 4S by R. One is 2S by R, other is 4S by R. See, this is 2S by R. Here we have 4S by R. This is for the soap bubble. That is for the air bubble. For the soap bubble, this is 4S by R. Okay. For in the air bubble, it's 2S by R. at what is centimeter depth is this much. Okay, so inside the air bubble, this is much the pressure inside the air bubble. Okay.